Let's talk about structured programming for 1 second. Now, we've been talking a little bit about methods and how we can put our own methods in code. And you're already familiar with using the main method, which is we've discussed is the entry point into a Java program, or basically when a program starts executing. Now, all languages have an entry point into the language, or when things start executing, the commands get executed. So here in Java, we have the main method, and we only have one line of code in the main method, just the infamous system.out println hello world. Now, what you can do is you've probably been tempted to put as much stuff into a method as possible. Like, for example, right now, we only have one line of code effectively, well, really only one line of code in our main method, but there's nothing that forbids us from putting in 20 lines, 200 lines, 2,000 lines. The problem with that, though, is the more you do in a method, the more unreadable it becomes. So let's just kind of pseudocode this. Remember, pseudocode is not real code. We're kind of pretending we're doing something to reinforce a concept. So let's just say line 6, we got a bunch of code to do something 1. Then on line 8 through line 400, do something 2. And line 10 would be like do something 3. So rather than having these as 3 comments, think about this as being 100 lines of code apiece. How about even better, like 1,000 lines apiece? Now, in a structured programming paradigm, it's not very reader friendly to do this. Generally, what we do is one of the uses of using methods is to take functionality and break it into logical segments. Very similar to like you would break books up into chapters, or you would take a bunch of files, or pardon me, a bunch of papers and put them into files. It's all about organization and how you want to organize this, and how you want to write structured code. So what I'm going to do is I'm going to use methods that kind of do that. I'm going to put in 3 methods that are going to do something 1, do something 2, do something 3. Now remember, what I'm talking about here is I'm not going to actually put any functionality in these methods. We're just basically designing this. And you're going to find out as you get through your programming career that designing code is really more important than just writing it. When you're really early in your programming career, it's hard to understand that because you just roll up your sleeves and you start coding. Roll up your sleeves and start coding. But as you get more seasoned at this, you start using what are called design patterns, like a good way to design, a program. A very similar analogy I bring up is like building a house. You can just get a saw, nails, hammer, and lumber, and just jump in and start building a house. But it's probably not going to be as good and as safe and as decent as it would be if you would have spent time designing your house and then building it. Software works like that. So what I'm going to try to emphasize here is the remainder of the video is we use methods to kind of enforce a good design and determine exactly how we're going to structure our program, just like a blueprint does to a house. It specifies where the bedrooms are, where the bathrooms are, where the kitchen are. It's not the house itself, but it's a plan for it. We're going to do that, or you're going to do that when you start designing software. It's called the functional specifications or functional spec. And it's a part of the design effort where you actually decide what your code's going to do before it actually does it. So what I'm doing here is I'm doing a design methodology called stubbing, stubbing, or abstracting, or latticing, or laddering. There's a lot of words for it where what we're doing is, see, if you notice, we're not really writing any executable piece of code here. What we're doing is we're just basically just kind of stubbing it out, where the functions are. So I guess what I'm doing here is rather than, having all this code in my main method that does something 1, do something 2, and do something 3, what I'm doing here is I'm taking that functionality and saying, you know what, let's write a method that does something 1, and let's write a method that does something 2, And let's write a method that does something 3. And then what we can do is in the main method, just call those different methods. That's a better design than just putting all your stuff all into like one method. Because you get some questions sometimes, like when do you use methods? That's like asking someone, like if you're organizing a bunch of papers, how many folders do you put this in? Well, how many folders do you need? Do you want to divide it by category, by subject? Methods are like that too. So I have 3 methods that I just programmed here. Do something 1, do something 2, do something 3. Now, I left one small error in there, but we're going to get to that in a second. So now what I can do is just replace all that code, presumably do something 1, like I said, had hundreds or 1,000 lines of code. Now I can just call that function, or that method, do something 1, and put the code in there. Now again, remember, the code's not in here right now because we're pseudocoding this. Or basically just kind of latticing out what the structure is going to look like. So on line 7, I'll just put in the code to call do something 2, and then on line 8, I'll put in the code to do something 3. Now, what you would do in this case is after you spec out do something 1, 2, and 3, is you would expand the design. You would just decide which arguments go into these methods and what these methods actually do. But you're going to find out that there's two discrete different steps in software where the design of your program and the coding of your program are really 2 different things. And you're probably just getting to that point now where it could start sinking in that sometimes there's a better way to do something than to put everything all into one method. Just like, building your house. You could build one huge room and put 8 beds in there, 3 bathtubs, 4 bathrooms, and a kitchen, but that doesn't mean it's the best way to do it. Software works like that too. So this is just a small illustration of that. So I added the code to do something 1, do something 2, and I'll just put in the code to do something 3. While we're at this, though, let me just kind of point out that that when you actually scale your program out like this, it's not uncommon to do something, or like we're doing here, and then add like your function code to do a little bit later. Again, when I say your function code, I'm talking about the code that actually executes and does something. This is kind of like a framework. So I guess what we're doing here is we're building a file cabinet, right? The file cabinet has drawers, and then in the drawers it has folders, and the folders are probably divided into sections. So that's what we're doing here with our program. Also notice that when you do this, you don't have to necessarily know what these functions are going to do. We just know that there's 3 things that need to be done. Again, in our design here, we could say, let's just say in our code, the first thing we want to do is calculate a raise. The second thing we want to do is calculate the possible percentage of a raise next year. And then we want to take that raise and determine how much of that money would be put to a retirement account. And I made up that functionality because it's our program, we're allowed to do that. But what I'm saying is when we're designing our program, we could think like that. We could say, well, if someone asks us, write a program that calculates a raise and then gives us a raise percentage and then tells us how much of that will be going towards a retirement account, you can logically say, you know what, that's 3 things. So how about we have a method for each one of them, each doing a specific part. That is a better design. So here we got our main method that just calls other methods. Very common. This is a industry standard common approach. I'm going to execute this and we're going to get an error message. Our error message is going to come up in a second. So now let me execute this program, and we're going to see that one error I was talking about. You're going to see an error calling for an invalid method declaration. You need to have it return something. Void means it returns nothing. That just means that you just call the method and it executes. It doesn't return anything. More about return values in a little bit in another video, but I think you kind of have used them so far. But just to point out that you need to put the return type in Java, what the method is going to return. So I just changed my code to have public static void, and let me give this a run. I'm trying to think if there's anything else I want to add here, but I think this is it. I just want to emphasize to you guys about methods, and methods are more of a design than anything, and I wanted to on purpose build a program that has 3 methods, and these 3 methods are being called, but they don't do anything. Well, why is that? Because I want to emphasize that methods are really structural. They're part of a design. Again, remember that filing cabinet, and the methods are drawers and folders in that filing cabinet just to keep it organized. Just like your filing cabinet keeps your papers organized, methods keep your code organized. It keeps it readable, it keeps it easy to debug, and it makes it maintainable. Especially, you might even have different developers working on different methods. Happens all the time. I'm finished, so thank you for listening. Thank you for making it this far in the video, and I bid you all a very well rest of the day. Thank you.